Alright, so on this problem we're going to look at finding the limit of a rational expression, and we want to substitute that infinity sign, but we do that a little bit tricky. So let's keep in mind that when you're looking at infinity, some things that are really important are your leading values, your leading coefficients and values. So to do that, we're going to take 6x cubed plus 3x squared, and we're going to put that over the bottom, and we're going to just reorganize the bottom a little bit so that our 7x squared is in the front. And then we want to reduce this down as much as we can to get a good look at it. So factor out a 3x squared, and that'll give us 2x plus 1. And then factor out on the bottom a x. That'll give us a negative 7x plus 1. And when you're looking at values that go to infinity, what's really important are going to be kind of your leading coefficients. And so we can cancel this 2 out and cancel this x out. We end up with 3x times 2x plus 1 all over negative 7x plus 1. Now, when infinity goes into this, when you look at infinity, this part of our equation right here will basically cancel out. Remember, when you're looking at like an umpteen jillion, trillion, this is going to be close enough that it's virtually 1, which then just leaves us with this 3x. And so as x goes to infinity here, it's being multiplied by 3. So we would say, in this particular case, that x is going to approach infinity. The other thing that you can do is graph this and look and see what your graph is doing on the left-hand side. And then what you'll see is the y values are always increasing. Since those y values always increase, your limit goes to infinity. Okay, here's another limit problem as we look at what happens when x goes to negative infinity. So I'll put a graph up for this guy. We can get a good visual. And the thing that we need to really investigate is what is the direction we're headed. So we're headed towards negative infinity, which is going to be somewhere way over here, way past negative 5. And the thing about it is this, that'll make it easier. You'll notice that on this graph, we get closer and closer to the x-axis with every bounce of the curve. And from the graph, we can infer that x is going to approach 0. The other thing is this, the cosine has a max value of 1 and a max value of negative 1. And so if that number on the bottom, if this x just grows larger and larger and larger, and the number on the top stays between 1 and negative 1, then your fraction will get smaller and smaller and smaller. So the result from that will be eventually you'll get close to, but not touch 0. And that's why we can say that the limit as x approaches negative infinity for this problem is 0. Okay, what we're going to look at on this problem is the limit of this function as x approaches 0 from the right-hand side of the number line. And this one is that easy. As you come in from the right-hand side of the number line, we want to know what value of y we're approaching. And you can see this graph is pointing up. It's going up. And this guy then is going to be equal to positive infinity.